Bismillahirrahmanirrahim. Assalamu alaikum, dear students. This is our next module, next problem. Problem number 6, fluid mechanics. First, we come to our statement. If you tried to smuggle gold bricks by filling your backpack whose dimensions are 56 centimeter into 28 centimeter into 22 centimeter, what would its mass be? Quite simple. Very easy problem. Okay, dear students, here while calculating volume, length, width and height, all the three parameters are given in centimeter, and because we follow MKS system, so first we will convert these three quantities into meter. Okay, length, width, height will be converted from centimeter into meter, as 56 centimeter will become 0.56 meter, 28 centimeter will become 0.28 meter, and 22 centimeter will become 0.22 meter. Okay, now let us come toward its solution. As in our previous modules, we start our solution from the definition of density. Okay, density is mass per unit volume. If a mass m of homogeneous material has volume V, then its density rho is given by rho equal to m over V. Equation number 1. Okay, dear students, here in place of a sign of equality, we can also put three parallel lines which will be which will denote that rho is defined as mass over volume. Okay, it does not make very much difference. Rho is equal to m over V, where m is mass and V is volume. Equation number 1. Okay, now we know from table of densities that density of gold is 19.3 into 10 raised to the power 3 kilogram per meter cube. Dear students, table of densities is usually given in appendix at the end of almost every textbook of physics. Okay, here we see table. This is the table. Okay, this is the table. Here density of gold is, this table has two columns. In the second column, at serial number 1 2 3 4 5 6 7, at serial number 7, or in other words at row number 8. Okay, because if we count rows, then this will also be counted as a row in which it is written material and density kilogram per meter cube. Okay, so density of gold is 19.3 into 10 raised to the power 3 kilogram per meter cube. Okay, if we do not write it in form of 10 raised to the power 3, then we will read it as 19,300 kilogram per meter cube. Okay, we know from table of densities that density of gold is 19.3 into 10 raised to the power 3 kilogram per meter cube. Rearranging equation number 1 as this. as m equal to rho v. Okay, m will be kept on one side and rho into v will be multiplied as m equal to rho v, and using 56 centimeter equal to 0.56 meter as I have already discussed. 28 centimeter equal to 0.28 meter, 22 centimeter equal to 0.22 meter. Now volume is equal to length into width into height. We get m equal to rho into v. Rho is given from table of densities, which was 19.3 into 10 raised to the power 3. If we do not write it as 10 raised to the power 3, then it will be written as 19,300 kilogram per meter cube into all these three quantities will be multiplied. Okay, 0.56 meter into 0.28 meter into 0.22 meter. Okay, this will become equal to 665.77 kilogram. Dear students, to this extent our answer is quite complete. We have solved our problem successfully. However, we can also give answer in shape of pounds. Okay, so if we want to convert this kilogram into pound, then we will have to multiply it with 2.205, then it will be converted into pound. Okay, so our answer will become 1468.02 pound, because within bracket I have already discussed that when this third dot is below these two parallel dots, then it is read as because. If this third dot is above the parallel dots, then it is read as therefore. Okay, so because 1 kilogram is equal to 2.205 pound, so many kilogram become equal to so many pound. Now we show the table. Okay, first we had shown this table in which density of gold was given. Now we show another table in which, dear students, here we can see that pound, 1 pound is equal to 0.4536 kg, and on the other hand 1 kg is equal to 2.205 pound. Okay, when we have to convert kilogram into pound, we have to multiply with 2.205. When we have to convert pound into kilogram, then we have to multiply with 0.4536. Okay, and this is the end of our problem. Okay, this is our solution. However, now we come towards the reference book. Okay, reference book is Physics for Scientists and Engineers with Modern Physics. Its author is Douglas C. Giancoli. Its publisher is Pearson, and its 4th edition 2009 has been followed or adopted, while its chapter number 13 under title Fluids is our relevant or concerned chapter, and this problem is enumerated at serial number 3 of the exercise of this chapter, that is exercise number 13.3. And this is the end of our module, our problem.